right. Can everyone hear me, I guess, even on the background, which is cool. Welcome to Rust for PHP developers. For those who don't know me, my name is Nuno Maduro. I am Laravel core team member, and I'm the creator of multiple open source tools on the PHP ecosystem, such as PastPHP, Collision, Larastan, OpenAI for PHP, and more. My main side project, besides working for Laravel, of course, is PastPHP. If you don't know what it is, it's pretty much an elegant PHP testing framework with focus on simplicity. So if you are curious about it, go to pastphp.com and let me know what you think. Now today, I hope everyone is excited because we are going to talk about Rust from a PHP developer perspective. And we are actually going to do a full live session of code, but before we jump on that, let me give you a little bit of the history of Rust. Most people think that Rust was created by Mozilla, but in fact, Rust was created by a Mozilla employee with the name Graydon as a regular side project. And Graydon was doing a lot of C and C++ at the time, and he said something like this on the creation of the project. My main audience for Rust are frustrated C++ developers who pick C++ due its performance, but they like to have something safer. Now, if you work with systems languages such as C or C++, you do face this kind of stuff all the time. Segmentation fault, double free or corruption, buffer overflow. This is pretty much what you face all the time, and Graydon wasn't happy about it. So what he made is he made Rust a memory-safe language to really fight all the errors we just saw before, but with the same advantages such as C and C++, which is bare metal performance. Now, Mozilla, which was the company Graydon was working at the time, they actually also saw the value on this. They thought, we use a lot of Rust, and we use a lot of C and C++ within Mozilla, and we are facing this kind of issues of memory safety issues all the time, in Firefox, for example. So they said, Graydon, just work on that full-time within Mozilla, and let's see more Rust within Mozilla itself. And actually that happened during 10 years. Rust is being heavily used within Mozilla, but in 2020 they got affected by layoffs, and the Rust team got disbanded or cancelled within Mozilla. Now, in 2020, a lot of companies were using already a lot of Rust, and they created this thing called the Rust Foundation. And this Rust Foundation is backed by very small companies, as you can imagine, such as AWS, Google, Meta, and Microsoft. So very big companies with a lot of money sponsoring the Rust Foundation and really ensuring that Rust moves forward with it. And to give you a perspective how much these companies are investing in Rust, this is a graph of the Android release, a product from Google. And this graph represents the memory safety vulnerabilities the Android software faces per year. And we can see that in 2019, the Android project faced more than 200 memory safety vulnerabilities. And 4 years after, which is the time graph here on the bottom, we can see that the Android software has now less than 100 memory safety vulnerabilities. So guess what changed during that 4 years time cap? Well, they're actually starting to implement more Rust within the Android software, and now they actually have the same amount of Rust and C code within the Android product. Google even said 0 memory safety vulnerabilities were discovered in Android Rust code. So all the new code they shipped on Rust, all of it had 0 memory safety vulnerabilities. And also, predominant members on the JavaScript community, which is Ryan, the creator of Node and Dino, both runtimes of the JavaScript ecosystem, he said, I have the most fun writing Rust these days, and I will never start a C++ project again. So this is a heavily C++ user who says I will never use C++ again. Now, besides the memory safety that Rust brings into projects, it also improves the developer experience a lot. There is this thing called the Stack Overflow Developer Survey, which is run every year, and Rust is, for the 7th year in a row, the most loved programming language in the world. with 80% of the, more than 80% of the developers who work with Rust want to continue to work with Rust. Now, because this is a PHP conference, I thought that it's funny to actually see where is PHP in all of this. So, well, now, to be really honest, it's a little bit different because people who started to work with Rust, they started immediately with the modern language, with all those features that Rust has. And with PHP, it's not fair. So PHP have 40% of the developers who work with PHP still want to continue to work with PHP. And this is happening, I think, in my opinion, it's because not everyone is lucky enough to work with modern PHP. So we have Composer, PHP Stan, PHP Unit in past, and not everyone is lucky enough to work with modern PHP. There is still a lot of PHP developers who work with legacy projects. Now, that being said, let's jump into some code here. So what we are going to do today is that we are going to do a simple CLI application on Rust. That will be a to-do list on the CLI where people can add a to-do and then display all the to-dos, okay? So a very simple, regular Rust application, and I'm gonna demo this showing you some equivalents in PHP so everyone can get familiar and get started with this. All right, I'm gonna jump here into my terminal and my Sublime Text, which is my editor of choice. Then I have this to-do backup in case things goes off rails, okay? Hopefully no. So the first thing we are going to do is install Rust on my machine. Just be mindful that installing Rust on my machine works in the same way that installing Rust on Ubuntu or a Windows operating system. And what you have to do is really type this command, this script called rust up. Okay, and I can download it with the curl, for example, and run it. And what rust up does, it's mainly installing two binaries on my machine. One is rustc, and the other one is cargo. Okay, so we are going to get those two tools, rustc and cargo, once I run this script. Once it's run, we get access to cargo. And cargo, to give you the equivalent on PHP, is pretty much the composer of Rust. With this, we can add dependencies, remove dependencies, and even start a new project. So this is the first tool we get. After cargo, we also get something called rustc. And rustc is pretty much the equivalent of the PHP binary. In the sense that with rustc, you actually compile code that you can run afterwards. And with PHP, you interpret and run code. So they are the equivalent, but in different languages. Now, again, with cargo, you can add dependencies, remove dependencies, but also start a new project. You can do the similar thing with Composer, create project. So let's do that. I'm going to type cargo init to do. Now, one thing to keep in mind here is that if I just do it like this, I'm going to create a new binary application. However, if I pass the option --lib, I'm going to create a new package, like a library, basically, to others can use. In this case, I'm going to remove the --lib, and I'm going to simply type cargo init to do. And this, as the feedback of the terminal is telling me, we are creating a binary application. Now, let's take a look about the file structure here. So I'm going to open this to-do on my left, and I'm going to open this file with the name cargo.toml file. The cargo.toml file is the equivalent of composer.json, meaning that we have all the meta information about our application. In this case, I obviously have my application name, which is to-do, the version of my application, which is 0.1. On the equivalent side on PHP, we actually use git tag to actually know the version of the package. However, on Rust, use this flag version. Then we have the Rust edition. The Rust edition is the equivalent of the PHP versions. We have PHP 5, PHP 7, PHP 8. However, with Rust, we work with editions, okay? And this is the edition required to run my Rust project. Then on the bottom, I have this list of dependencies, similar to Composer required dependencies, where I can specify which community dependencies my Rust project is using. I could come here and do something like chrono equals to 4.0.0, and this would simply mean that my project uses the community datetime library of Rust, which is chrono. For my CLI app, I actually don't need any dependencies, so I'm going to keep this list empty for now. Now, I want to show you the cargo.log file, which is another file, and for that, I'm going to compile my project for the first time. And to do that, I'm going to simply type cargo run to see, I need to enter on the folder first, and then I'm going to type cargo run. Now, when I type cargo run, the first thing I see on top is the compilation steps of my project. So I can see that my project got compiled and then finished compiling. And after is kind of executing the binary, the result of the compilation. And I can see hello world on my console, which is exactly what my source code is telling me to do. Now, once I run cargo for the first time, I can actually run cargo run -q, which is my favorite way of running cargo, which basically hides all the compilation steps I see here on top and just prints exactly what my program is printing out. So once we run cargo for the first time, I get this file, which is cargo.log. And this is pretty much the equivalent of the composer.log. It's basically a manifest of the dependencies used by my project. Then I also have this target folder, which contains all the temporary files result of the compilation. I kind of want you to ignore this folder for now. Just be mindful that this target folder represents some of the temporary files used on the process of compilation. And then we have our source directory, so pretty equivalent to PHP. However, within this source directory, we have our main.rs file. The main.rs is the equivalent of the public index.php, which is the entry point of your application. And I can see as well that within this main.rs, I have a function with the name main, which is equally the entry point of my app. And we can immediately start understanding some stuff here about Rust. The first thing is the declaration of functions. I can declare functions with the fn keyword, then giving the function name, and then the list of parameters. Now, as you can see here, the type is not specified. This is one cool thing about Rust, is that the type inference is very strong. So here, if I wanted to be explicit, I can say that the return type of this function is void. So this is the equivalent of the PHP thing like this, basically. So here, this function is returning void, meaning nothing. And then I have a macro printoln, which is like a function that displays hello world, and of course, if I run cargo here, I get to see hello world on my console. So again, we are doing a CLI application, so probably the first thing we need to do here is explain the usage to the user. That will be something like usage to do, which is the way I want to use my application, and then to do, and then I pass the command, and finally a list of these arguments. Okay, so obviously if I run cargo, I should see this on the console, which I do. So what I can do just below is type now the list of commands. And the list of commands will be basically something like this. Commands equals to 2 commands, by the way. We are working with 2 commands today. One of them is to basically, people want to run cargo run, add, and then the to-do description, like to-do 1, for example. And the other one we are going to build together is the list, to basically display everything we have added to the to-do list. So let's explain that to the user. This will be the add command, which receives a description as an argument. And this command adds a to-do. And then just below, we have the list command, which basically displays all to-dos. If I run this with cargo, hopefully things are still working as expected, which they are. Something I can do here to make this a little bit more sexy is give some space here, okay? So I'm gonna do that. Oops, cargo run -q. There we go. And I get to see the usage right on my terminal. Now that we know a little bit about functions, you're looking at this function main, something we can do is extract this usage to a new function with the name display help. So let's do that. Display help returns void. And then the function body will be pretty much a copy-paste of the content of my previous main function. And here I'm going to call display help to get to see the usage in the same way, which I do. Now, once we have the usage, the user actually will interact with this CLI tool doing something like cargo run and then passing the command, which can be add or list. So we need to actually capture the arguments of this CLI application. Now, to catch the arguments, we can actually use something built-in on Rust, call it the envs from the standard library. I want to talk a little bit about that. So in Rust, actually I want to talk about variables before that. I'm sorry. So to catch we need to catch the arguments and then the command, but we need to store those values somewhere, and we usually store that on variables. And let's talk a little bit about variables on Rust before we actually talk about the standard library. So variables on Rust are not actually variables, meaning that they don't change the value. They are immutable by default. This is a little bit different from PHP, as variables can change. They are actually variables. So on Rust, when I type something like, I'm going to just do this on a main. When I type something like let command equals to add, and then I just type below command equals to list. On PHP this would work, meaning that the value of the command will change. However, on Rust, once I try to debug what is within command, you will see that Rust will start to complain. So a couple of things here we need to take a look of. The first one is that the Rust compiler on the console is telling me that you cannot assign twice to an immutable variable, meaning that I have assigned the value add here, but then after I have tried to assign a different value to the variable command, and that will not work in Rust. So the variables are immutable by default. Now, thanks to this great developer experience on the console we get to see here, we can see that Rust is telling me that consider to making this binding mutable, which can be done by the mut keyword. Meaning that if I come here and I just type let mut command, I now get to see on the terminal the value of my command, which is list, right there on the bottom. However, Rust is very helpful again on the console. It's really just telling me, oh, you're just assigning like command to add and then you are overriding just below. Doesn't make any sense. Therefore, I'm going to tell you a warning here. However, my program compiles, and that's thanks to the mut keyword, which allows me to mutate variables. So again, variables are immutable by default on Rust. And now that we know how to actually create variables, we can start to collect the arguments coming from the CLI and be explicit about this, this variable. I'm going to say that the args is a vector of strings. This is the equivalent, the vector in Rust is the equivalent of the array in PHP. However, we can say what is within the vector, which is values which are strings. So within the args are a vector of strings. And this vector of strings will be something from the standard library, call it standard library env, and then give me the args from the env standard library. So I want to talk a little bit about this. The standard library in Rust is pretty much some common helpers that are commonly used within Rust projects. Even on every language we have this, is pretty much helpers for people building applications. On PHP we have like the global env and the global server variable. We have a bunch of array functions. We have a datetime library as well, which pretty much allows you to build PHP applications with those helpers, okay? In Rust, we have this standard library, which gives me access to specific modules. One of them is the env module, which we can grab the arguments from this. So obviously, if I try to debug this, so I'm going to do that. Hopefully, I have all the arguments on my console. I have a mistake here. I can import this. This is like this. What? Vector of strings? What? How to do this? What the fuck? What the hell is happening? Give me a sec. That's why I've created to-do, huh? Oh, I need to call the collect, of course. I'm sorry about this, guys. That's why you have the backup, huh? Just in case. All right, now it's compiling, and on the bottom, I have on the line 8 my vector of strings, which is displaying by binary. However, I can add the command, and now I have displayed on my terminal the add command on bottom. I can pass a description, for example, and I get to see that description on my vector of strings. So As you can see, we can use this function on Rust, dbg, which is pretty much the equivalent of a var dump in PHP, and we can see the values that are compiled in runtime, and we can see these values on the terminal. So once we get the arguments, remember, we are trying to capture the command. So when I type a cargo run add, we need to capture this value to then do something with the command. As you can imagine, if we have the add command, we need to do some code. If we have the list, we need to do something else, which is displaying all the to-dos. And after, if we have something that doesn't make any sense, we need to tell to the user that the command is unknown. So let's do that. Let's capture the command by doing something like let command equals to args get the index number 1, because remember, the command is within the index number 1. And one thing cool in Rust, which you probably would expect to see here, is that in PHP we have this thing like isSet. If the array key exists within the array, then we capture the value. Well, on Rust there is no nullables, okay? So here I need to tell to Rust the following. Okay, unwrap the string within the key number 1, or else, which is otherwise, we need to execute this default callback. So I'm going to do that. I'm going to say, okay, if there is anything on the position 1, which is the case right here, however, it's not the case when I don't run any command, I want you to get me back that string. However, otherwise you execute this default callback. And when the user doesn't provide the command, what we need to do is display the help, just like that. And then we need to exit the program with feedback, with the exit code. I'm going to do that using the process module from Rust, again, an helper. And I'm going to exit with the static code, with the status code 0. And I need to import this module right here on top. So standard library, process. Okay, so let's see how this is going. Let's debug here as well the command to see if we can capture the add or the list. So I'm going to cargo run -q, and I get to see the help, meaning that we are entering on this default callback. The key number 1 does not exist. However, if I run cargo run -q add, I get to see the add on the console, and I get to see a list. Now, one cool thing, and you probably get this same feeling with PHP standard level max, is that if the program is compiling, meaning it's kind of working as expected. And that's a very cool feeling with working with compiler languages such as Rust, is the feeling that if it's compiling, it's kind of working, unless you make a typo somewhere, which is a very good feeling when working with Rust. Now, again, at this point on the command variable, we have the add value, we have the list value. However, we also have something that if the user types like blah, 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 which is nothing at all, we have the command with this value, which doesn't actually represent anything. We don't know what to do with it. So we need some control flow to do something when it's add, to do something when it's list, and to do something when the value doesn't make any sense. And for that, we can use the match expression. The Rust have pretty much the same stuff as PHP. So we have if conditions, else conditions, we have the match statement, which is exactly what we are going to use. And the match can be done with something like this. Okay, let the exit code be the result of the following match expression. If the command, a string, is equal to the value add, I want you to do something within this block of code. If the command is list, I want you to do something else. However, if the command is something that I don't know, meaning I want to enter on this default scope, I want to do something else. And finally, now that we have an integer of 32 bits on the exit code, what we can do here is simply exit with that exit code. And of course, we need to get an exit code from this match expression. So we need to type some code here, actually. So I'm going to type print new line with adding a to-do, and return back the integer of 32 bits 0. Now, one very cool thing on Rust is that if you have something like this, meaning that you have a return plus a semicolon, there is this syntactic sugar, which is you remove the semicolon, and then you can remove the keyword, which is pretty cool. So some syntactic sugar. So if you have this is the equivalent of having this. So you just hide the semicolon, hide the return statement, which is, in my opinion, pretty cool. I used to see more of these things in PHP, to be honest. Then we can do the same stuff on the list command. Instead of adding a to-do, we are obviously displaying all to-dos and returning 0 at the same time. And finally, of course, so if we enter on a default statement, meaning that we don't have add or list, we need to say to the user, unknown command. And you need to back off with the exit status 1, which is an error. So let's see how my program is doing. I'm going to type cargo1-q, displays the help, makes sense. -q add, which heading a to-do, and then list to display all to-dos, and then blah, blah, and I get to see unknown command. So, so far it's working as expected, except doing the proper job of storing to-dos and displaying all the to-dos, but I think it's working right. Before we actually talk a little bit about the concrete code that will store those to-dos in the persistent layer, let's actually refactor this a little bit, because at this point my main file have 42 lines, and for the same reason you don't store your code on the index.php, you probably organize your code on PHP and within folders, within classes. In Rust it's the same stuff. We basically refactor all our code when we have to. So looking at this application, on PHP, how would I tackle this problem? I would probably use Symfony console for this, and I would probably have a separate class with the name add command to actually handle the process of storing a to-do. And then I would add a list command to actually display all the to-dos on my terminal. So let's do that on Rust, or at least try to do the same thing. So what I'm going to do here is that on my source directory, I'm going to create a new file. That file will have the name commands.rs function. On this file, I'm going to store the code of my add command, and I'm going to store just below the code of my list command. Again, we don't have classes on Rust, but we have something that they say it's not similar, but it's kind of it is. So we can do kind of the same thing with something called a struct. So here I'm going to create something called struct add command. And within this struct, I can have properties similar to classes on PHP. So here I could have something like name equals to a string, and then I could have, for example, an age equals to an integer of 32 bits. There's a lot of data types on Rust, like integer of 32 bits, unsigned integers, which are positive integers. However, today we are going to not talk about that too much. So I want to my add command did not have any properties for now. However, I need to have at least one method to handle the process of storing the to-do on the persistent layer. So let's add actually some methods to this struct. The way we can do that on Rust is not within the struct definition, it's just on the scope below. So what I can do here is something like implement add command, and then I'm going to put all the methods within this implement add command scope. And I'm going to do is create first of all my constructor. The constructor convention on Rust is using this new function name. So new function returns a self, which is the structure, basically, pretty much the self on PHP as well. And then within this self, within this function new scope, I'm going to return the add command without any properties. However, remember this, when you have a semicolon, we can remove the semicolon, remove the return keyword, and make this code a little bit more simpler. So this is the equivalent of a construct in PHP. And just below, we need the method for the struct, which will actually handle the process of having a to-do to a persistent layer. So let's do that. I'm going to type function handle. And then I don't want to actually create a static method. I want this method to be an instance method of my struct. So I'm going to pass here self. Okay? This is the equivalent of this in PHP. Okay? So the handle will return back an integer of 32 bits. Remember, we need this back to our match statement, to the exit code. So this handle will return an integer of 32 bits. And within this scope, we are basically printing out what we had before within our match statement. So I'm going to copy this, head to within my handle method, and just save this. So to let it very clear, if we pass the self within the arguments, meaning that this function is non-static, is an instance method of the struct, if I don't pass self, this method becomes static, similar to PHP. So in this case, I want this to be an instance method, so I'm going to pass self. And finally, let's actually use this struct, aka class in PHP, within our main match statement. So I can remove all of this thing and simply type add command new, so I can call this method statically because I'm not passing any self argument here. However, the handle method is non-static, and that's because I'm passing the self here. So add command, new handle, and that should pretty much return back an exit code. Let's try to compile our application to see how this is doing. So I'm going to clear my terminal, run cargo, and let's use the terminal feedback to actually proceed with this. So cargo is telling me on the right that the add command was not found within the scope of the main function. So meaning that the struct was not imported. So let's do that in the similar way we do in PHP. We just go to the top. One difference in Rust is that I need to declare the module commands. Okay, so on my main.rs, I need to declare every single file that is within my source directory. And then I can import the struct by doing use commands add command. So I've imported. Let's run cargo once more and just follow the feedback. Now, cargo is telling me that the add command that you just have imported within our main.rs file is a private struct. Another very cool thing about Rust is that structs are private by default, meaning that when you create this struct add command, it's private to the commands file, and you cannot use it elsewhere, unless you use this keyword pub and you make this struct public. I'm going to clear my terminal, run cargo once again, and let's see how it goes. Next, the terminal is telling me that you are calling the new and the handle method. However, both are private. Okay? So functions implemented on structs are also private by default, meaning that I need to come to this function new and actually make the function public to be able to use it outside of my file. Cargo run, we get to see the display help, meaning that I'm pretty sure that my program is working as expected. So if I type cargo run add, I get to see adding a to-do, which is the result of my handle function. Everyone is enjoying or not, huh? Cool? Okay, that's cool. Let's move forward here. So we need to do the same thing to the list command. Let's do that, because right now we don't have a list command yet, meaning that the code getting executed is within this match statement. So let's do the same behavior we have done with the add command. So I have this code right here. I'm going to simply copy paste it like a good old days. Bam, put here on the bottom, and then rename some stuff here, obviously. So this will be the list command, which returns a new list command. And finally, the handle method, instead of having a to-do, will display or displaying all to-dos. Okay? So hopefully, let's run cargo. Actually, let's use this struct within my match statement. So this will be list command, give me a new instance of that, and then handle the job. So if I run cargo, let's see what it tells us. It's telling me, of course, that the list command is undeclared, meaning we need to import this struct within the main RS. Now, one cool thing, and I wish to see that in PHP as well, is that when you see that you are importing everything from the same file, something you can do is this thing right here, bam, and just imports everything from that file. It's kind of a wildcard that basically imports and makes sure that everything on that file commands is exposable within the main.rs function. Nice synthetic sugar again. So this is pretty cool. I'm going to clear my terminal, run cargo. I get to see adding a to-do, so I'm kind of sure that the list is also working as expected. Again, when Rust compiles, unless you have made like to-do in English, which is difficult with Go Copilot these days, meaning that your program is kind of working as expected. All right, cool. Let's talk about interfaces, because, I mean, looking at these two commands, we have the add command and we have the list command. Something that is kind of similar here is this handle method, meaning that both these structs implement the same handle method in the same way, meaning without arguments and returning back the exit code. So something we can do is just say, okay, both the list command and the add command and maybe other command in the future needs to at least implement the command interface to make it all of them look similar. So let's talk about interfaces on Rust. This actually will be fun. So I'm going to go to my commands.rs module, and I'm going to declare here on top my command interface. Now, One difference, though, on Rust is that you actually declare an interface with the word trait. Okay? All right, calm down, huh? So on PHP, you have this thing called a trait, which allows you to actually share methods between classes. People are not actually sure about it, like why people are still using it. However, on Rust, in order to declare an interface, use the keyword trait. Okay, so in this is exactly the same stuff as typing here, like in PHP, interface command. Okay, the difference is that similar to PHP, we can specify what this interface is actually forcing the definition of, which is a handle method which receives self, meaning non-static, and then returns back an integer of 32 bits. This is my interface definition. However, on Rust, you can have default implementations, meaning that you can provide, okay, the struct who implements this trait will have this method that works this way. So you can provide a default concrete implementation for the structs implementing this interface. For now, I'm going to do similar to PHP, meaning that I don't want to provide a default implementation, meaning that it's up to the struct to define the concrete implementation of the handle method. So once we have the interface traits in Rust, we can copy the name, and you probably would expect to do something like implement command. It doesn't work that way, okay? So I'm going to remove it here, and I'm going to go just on the bottom of the implement add command. I'm going to say the following. The implementation of command for add command is the following just below. So it's not within the struct definition, it's not within this first implement add command, it's just below. Implementation of command for add command is the one within this two brackets. And then we need to put all the methods defined by that interface within that scope definition. So I'm going to copy this function handle, all of it. I'm going to remove it here from the methods without any interface. And I'm going to copy it just below, right here. Okay? Now, one cool thing, which I also wish to see in PHP, is that usually when you have an interface, you are kind of defining the public API of a specific class. Nobody creates an interface with private methods, right? So here, what in Rust, if you are defining an interface or the concrete methods of an interface to a struct, all the methods are just public by default. So meaning that you can remove this pub keyword, okay? Which is pretty cool. So hopefully, things are still working as expected or not. Let's see. Cargo run. Oh, it's complaining. And now it's complaining about the struct add command does not have a handle method. And why? Because interfaces or traits in Rust are actually private by default, meaning I need to make this interface public to be used outside of the scope of the commands. Let's run cargo once more, and hopefully it's working as expected. It's not working as expected. That's because I need to save it, I guess. Let's see. Of course, I need to save it. There we go. It's now running and compiling, which is pretty cool. We can do the same thing for the list command. Let's do that. So here on the list command, I can just do right here, implementation of command for list command. It's the one that we had on the method handle. Remove it from here on the top, put it within the interface definition, removing the pub keyword. Again, doesn't make any sense. It's public API. Let's run cargo. And of course, is working as expected, which is cool. Okay, we got to see variables, functions, interfaces, structs, data types, all this craziness. Let's actually start coding the code responsible to persist the to-do and then display all the to-dos. And I wanted to be mindful of, you really just need to do Rust, you really just need to know these concepts of cargo, how to run cargo, how to install it, and then how to create structs. This is not the only thing that you actually need to do, okay? When it's come to really concrete and complicated code, Go Copilot will basically do everything for you, okay? So do not memorize everything I'm about to show you, okay? So the have command, which is right here, we want to actually start to persisting these to-dos, okay? So to persist a to-do, the first thing we need to do is grab the description of that to-do, right? People are going to run this command on the following way. Cargo run, add my to-do description 1, for example. So need to provide this description of the to-do. So the first thing we need to do is grab the arguments, and I can do that typing let args. Actually, no. I need to provide those arguments on the arguments, because remember, we have already the arguments in our main function right here. So we need to provide this thing to the add command struct. And the way I'm going to do that is actually by declaring a new property of my struct. This struct will have a property with the name args, which is a vector of strings. And then on my constructor, which is the new, I'm going to actually give to my struct those arguments. So this will be equally a vector of strings. And finally, I need to pass this argument into the property of my struct. So I'm going to do something like this. Now, again, some syntactic sugar of Rust is that if the property name is equal to the given argument, you can simply do this. Bam. And it's exactly the same thing, okay? So having this or this is equivalent. So I can just remove this and give to my add command the arguments, and let's debug those self args. So self, again, is the equivalent of this. Let's debug those args to see if we have something on our handle method. Okay, Rust is complaining, is telling me the following. When you create a new instance of add command, and that's done on the main.rs function, which is right here, you are not providing a vector of strings, meaning that we are missing the arguments argument. So let's do that. Provide here, there we go, and run cargo. And we now have the list of arguments within our command handle method, meaning that we can grab the description of the to-do. So the description, I can see that if I type my to-do 1, I get to see that on the index number 2 of my vector. So we need to type something like this. Let description equals to self args get the index number 2. Now remember, a description may or may not be there, because if the user provides cargo run add without the description, we may not actually have an index number 2, meaning that at this point we don't have null, we have instead a description option, which we could unwrap or else, as we have seen on the main function. However, this time I'm going to do something different. What I'm going to do is just say this. If you have some description, and that may come from the description option. I'm going to make this a little bit bigger so everyone can follow. There you go. If you have some description coming from the description option, I want to execute this code right here. And for that, I'm going to simply debug the description itself and then return back probably 0, because we are going to add the to-do. Otherwise, I want to say to the user that description is required, and return back the exit status code number 1. Okay, so let's recap. We are grabbing the description, which is an option, may or may not be there on the index number 2. Then, if we have a description, we are going to output that description, or else, of course, saying to the user, description is required. So I'm going to clear my terminal here, make this a little bit bigger, and I'm going to type cargo run add without any description at all. And it's telling me description is required, and I get to see this red thing, meaning that the exit code was 1. And if I type cargo run add to do 1, I get to see exactly that on my terminal, meaning that I'm entering on this if statement right here. Now, at this point, we have a description, which is a string, and we can store it somewhere on my computer. So what I'm going to do to follow a very naive implementation is that within my root directory, I'm going to create a file with the name storage.txt. Okay, so within this file, we are going to put all the to-dos people are using our CLI tool. So then what I can do is use a module from Rust called a file system. So here on the top, I'm going to scroll here. I'm going to import a module from Rust from the standard library. Again, very common. All languages have something like this. And I'm going to import the file system module from Rust. Then just below, what I'm going to do is, and again, no need to memorize all of this, is type something like this. Okay, let the mutable file to be equals to file system, open options, new, and I want you to open that file for writing on append mode, And finally, the file name is the one with the name storage.txt. If something goes off Rails, which it shouldn't go off Rails, but if something goes off Rails, I want you to type file not found. Okay? So at this point, we are opening this file for writing, and what we can do is simply type now, okay, write on that file the contents of my description. And this will basically increment every description of the to-dos on bottom. So let's run cargo to see how it goes. I need the exclamation point here. There we go. Cargo run add to-do number 1. I get to see an error saying that method not found right in the new line. Okay. Description. Give me a sec. No, print will print out, huh? In this case, I just really want to write on the terminal. You know what? I'm going to do something different. Okay, this should work. Otherwise, I have the backup, huh? Okay, I'm going to see the backup real quick, huh? Yeah, of course. Okay. So what we're going to do, again, yeah, of course, on the write ln function, I actually need to pass the file as a first argument. So again, on this case, what I'm going to do is say, okay, write me on this file the contents of this description, and here I can simplify this a little bit by doing this. Write the contents of this description. However, if something goes off Rails, we can expect the file to not be writable, okay? Once I do this, I can give feedback to my user, so printing, and a new line, so now to the console, to-do added. Let's run this on cargo to see how it goes. So again, without anything, it will complain, oh, it's actually still not compiling. And this is because in order to use this function with the name write ln, I actually need to import this on top. So let's do that. Clear my terminal, run cargo again without a description. I'm supposed to enter on the else condition just below, and I am, so description is required. However, if I type cargo to do add, and then to do number 1, for example, I get to see to do added, and that it's pretty much sure on my, not this one, there we go, to do number 1. And if I do this with, for example, to do number 2, I get to see that as well on my file, which I think is pretty cool. Okay, so now that we are able to add to-dos to this file, the last step is really displaying all the to-dos when we are typing cargo run list. So the way we can do that is simply by modifying the code of the handle method within the list command. And that can be done very simple by doing something like this. Let the contents to be equals to file system, read to string the contents within the storage.txt. However, if something goes off Rails, I want you to type file not found. And once we have the contents, we can use the very old print new line. This is the equivalent of print in, in PHP. And I can do print out the contents of that file to simply have a naive approach of displaying all the to-dos. So again, cargo run add to-do number 3, for example, to-do added, pretty cool. And I can now run cargo run list to get to see all the to-dos on my terminal. Again, a very naive implementation, but get the job done. And we just have saw how to create a CLI app on Rust, which I think is pretty cool. All right, I hope everyone is excited about Rust, at least in the way I am. I want to show you one more thing before we close this off. I want to show you testing, okay? Now, testing on Rust works a little bit different from what you would expect. In PHP, we have to import or require a PHP unit or past, and then we need to create a folder with the name tests, and then a separate file for each test case. So there's a lot of writing. And Rust is a little bit different. So in order to have tests, for example, for the commands module, you actually write those tests on the bottom of the file. That's correct. So on the same file that you have your source code, just below, you will have your tests. So what we are going to do here is just have a separate section for our tests. And then I'm going to type this tests module code. So basically telling to Rust that, OK, all the code below is related to tests. So within my module tests, I want to import everything on this file. That can be done with a super and then the wildcard word. And then we have this annotation to specify that within this thing is a test. Now we can have two tests just to showcase you how testing works on Rust. So what I want to do here is simply do add command, for example, to have a test. And remember, for the add command, we need to create a new struct with the name command, for example, and then we need to pass the arguments to that struct add command. So I'm going to first of all create an array of arguments. That will be a vector that contains within the binary on the first position, remember? So this will be a to-do to string. Then we have the command name, which is add, to string as well. And then we have the to-do description, which is something like my to-do number 4, to string. Okay, so once we have the arguments, we are kind of preparing our test. We can create a new struct of the add command. That will be command equals to add command, and call the method static method new, which is the construct. Within this new, I can pass my arguments, and I have successfully prepared my test. I can now act just on bottom. That can be done by simply storing the exit code as a result of the command handle. So kind of acting to then assert, right? So on bottom, what I can do is just call this section assert and just say, now this is kind of similar to PHP though. I can type assert equal and then provide what I'm trying to assert, which is the exit code to be 0. Okay, so let's see, let's run this thing to see how it goes. And also different from PHP is that you would expect to run like vendor bin PHP unit or vendor bin past. And in this case, you just type cargo test, which is kind of built-in within cargo. So if I run cargo test, you see a lot of stuff on the terminal. Again, to avoid this, you can simply clear the terminal. Cargo test -q just hides all the compilation steps because you don't need to see them. And I get to see that my test result is okay, meaning that I get an exit code 0 from my handle method. And if I would, for example, pass 1 here, obviously my test would fail with the exit code number 1. So let's run that. Cargo run -q, and I get this feedback on my console that the left value is 1, however, the right one is 0, meaning that my test is failing. So I can put 0 to make this test pass. And then just below, I can do the same stuff for the list command, which I'm going to do. Okay, I'm going to just copy paste and then call this list command. To prepare my list command, I don't need any arguments at all. So I'm going to just create an argument without those arguments. I'm just listing the stuff. Then I'm going to call the handle method, get back my exit code, and assert the exit code is 0. Let's run cargo test -q, and I get to see that both of my tests are passing and the test result is okay. And this is pretty much what I had to show you. A couple of small notes. Today we just have saw a very naive implementation of Rust as a CLI application. Of course, Rust's use cases are way more diverse than this. Here, for example, I have my website, my blog actually written on Rust. So if you want to see a little bit what Rust code looks like in production, just go to my GitHub, nunomaduro.com is the name of the project, and you get to see some of the interesting and spicy stuff on Rust, such as asynchronous, multi-threading, so very cool and safe stuff. On my GitHub, you will find a couple of Rust projects, including a CLI framework, actually. So this project is held on github.com, nunomaduro/nunomaduro. This was Rust for PHP developers. I hope everyone had fun watching me coding and making mistakes, which is pretty cool. Feel free to follow me on my socials. I have Twitter, Mastodon, LinkedIn, YouTube, and just if you have taken pictures, don't hesitate on putting them on social media. I like to see them, okay? Thank you so much.
Yeah, thank you, Nuno. This was really fascinating.
Thank
Does
you.
anyone any questions?
So I was wondering, like, do you have any tips or examples of where we can go to learn once we've mastered what you've already shown?
Yes. Actually, I'm going to tell you the way I've learned Rust, which it might work for you. I hope so. So the way it worked for me is that I started to learn by the Rust book, which is the name of the official documentation of Rust. To be really honest, they write very simple words, even for a non-native English like me. And I felt that I really learned it just from the Rust book. And then also that something helped me a lot is with GitHub Copilot, you get so much auto-completion when you are like, when you are facing problems and you don't know how to solve them. You just actually ask GitHub Copilot, it will just write the code for you. Even if it's not like the very correct one, you at least you are able to learn from there. So yeah, Rust book is pretty much my way to go when running Rust. However, play with it and play with GitHub Copilot as well. It will basically get you on the rails, I feel like. You're welcome.
Anyone else?
Actually, I tell you what, I've got two, in which case, very quick one. Very quick one is, I noticed you had self in capital S and lowercase.
Yeah.
Is it case insensitive as a language?
No, meaning that you would, well, actually I need to double check that. But in the case of the self, so when you are returning back, I'm gonna actually go there real quick. You were talking obviously about this self right here. So when you are here I could do two things. I could do, for example, list command, just basically specifying the struct I'm returning on. But you can basically use this syntactic sugar and say that you want to return self, and this needs to be uppercase. However, when you are using the self argument, which is the this on PHP, you need to be lowercase here, okay?
And then what sort of is the infrastructure behind it, frameworks and all that sort of thing? How does it compare to PHP?
That's a good question. So I can tell you from experience, again, I'm not an expert on Rust, but from experience, in order to serve a PHP application on the DigitalOcean droplet, for example, I would need to put it behind Nginx, and you have PHP FPM, and all these different tools that basically I kind of use as default configurations because I don't know how to configure them. However, on Rust, I simply had to proxy Nginx to my server on Rust, and that was basically working. So I had that on Ubuntu, a very simple server serving my Rust application, web application, and then I just had Nginx proxying all the requests to that server, and that's it. So no PHP FPM equivalent for Rust.
All right, anyone else?
I think I saw you tweet once that you were looking and experimenting with other languages to find some new ideas for PHP and for your packages and stuff.
Yeah.
So I was wondering if there are any things, some things you found in Rust that you want to implement in
Yeah,
your own
actually,
stuff.
good, excellent question, by the way. So something I have actually ported to Laravel itself. So on Laravel, we have this PHP code where you can actually var dump values. So you can use something like dd value and then have the console outputting the string value. So something we didn't have, and you can find it on Rust. I don't know if you have noticed, but when I was executing my Rust code, you get to see this, where is it? Well, you get to see next to the debug value, the origin of the dd, basically, you know? So when you're using on Rust something like this function, like dbg, and then you put actually the command inside. On Rust, you see the value of the command and also the origin of the value, the file where it's coming from. On PHP, we didn't have that, at least on Laravel DD. So now we actually have ported this thing, and when you divar dump some value with the dd function on PHP, you get to see also the file on the console. So that's something I actually was able to port to PHP, which is pretty cool.
All right, the last question before was cake time. See?
Thank you, that was very good demo. I have a question about the add command where you used if-else statement. And I was wondering, could you use unwrap or else like you used in main.rs?
A good question, yes. I could use the unwrap or else. However, on that case, I want to showcase a little bit about the if syntactic sugar here, which is, okay, if you have something, create a variable with it. That's why I've kind of showcased it this way. So you always get back an option when you are using something that may or may not be null. So in that case, you can do something like this, which is creating a variable out of an if condition. However, you could also do, as you have mentioned, unwrap or else, which is more like, okay, unwrap the string, otherwise execute me this default callback. So I wanted to showcase both. That's why I've done it differently. Good question.
Thank you, Nuno.
And thank you.
Let's have another round of applause.
Thank you.